This is AP Calculus 3.1 Part 2. We're doing more with the chain rule, and today we're going to talk about the chain rule and its use with trig functions. This is where students, if they're going to struggle with trig functions, this is usually what causes the problem, because a lot of times when you're doing trig functions, it's really easy to forget about using that chain rule process. And so we have to be really careful and really pay attention to what we're doing when we're dealing with trig functions and the chain rule. Not only are we going to have the normal trig functions like you see here, and at this point you should have your trig derivatives memorized. If you don't, this section is going to get very difficult for you. So make sure you've committed these to memory, make sure you know them well, and make sure you understand that the negatives, if it begins with a trig function that starts with a C, their derivatives will always be negative. That's a common mistake that I see students forget the negative signs. So when we're dealing with trig functions, what you have to remember with this is every time we do a trig function, we've been doing the chain rule, you just didn't know it yet, because so far the only thing that we've used with these trig functions is all of these have been x's. They haven't had any kind of function in here in place of the x. But now, instead of just having an x, like cosine x or sine x or tangent x, we're going to have something like sine 3x squared or cosine 2x, or we might have tangent squared of 3x squared minus 5. We could have all kinds of different applications of the chain rule with your trig function. So we're going to start out simple. We're going to work our way to the more difficult problems, and hopefully by the end you'll be able to do some practice on your own. So just to review, the derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of cosecant, negative cosecant, cotangent. Derivative of secant, secant tangent. And derivative of cotangent is negative cosecant squared. Remember, whatever your x value is has to be right beside every single trig function in your answer. So you can't leave that out. Like, we can't just say sine x, the derivative of sine x equals cosine. The derivative of sine x is cosine x. Okay, derivative of cosine x is negative sine x. So we have to include that. I call it the angle part, whatever the x is, whatever this is, I call that the angle part. It has to be included. And with the chain rule, when you have an angle part that's different than x, you then have to, that's considered your inside part. So then you have to multiply by its derivative. So here I've got a simple function. And what you have to understand here is we have a coefficient in front. We treat that just like we did before. It can come down as part of our answer. And then we have a sine of, here's the angle part, okay? Now, the derivative of this part, well, we bring down the 3. Derivative of sine of 5 plus x squared is cosine of 5 plus x squared. But then we have to take this part, this is what I consider my u part, and I have to take the derivative of the u part. So that's 2x. Now, I need to be careful. I don't want to think that I can multiply that 2x by what's in here. So normally when I do these, I will write down the 3, I will leave a little space, I'll put the derivative of the trig function, cosine 5 plus x squared, and then I'll take the derivative of this and just move it to the front. Because you need to understand the derivative of the angle part cannot be distributed into the angle part. It's a separate part of the problem. It goes to the front. I could multiply these if I want to, but there is no need. You don't have to do that. So you can have 3 times 2x times cosine 5 plus x squared, or you could have 6x times cosine 5 plus x squared. For the next one, with this, my u part is not quite as easy. I'm going to rewrite it first. That's cosine of x to the 1/2. Then I'm going to take the derivative of that. So y prime equals, I'm going to bring down the negative 2. The constant in front stays there. Derivative of cosine, well, derivative of cosine is negative sine. So I need that to be a negative sine. That means I get rid of the negative there. So that's a negative sine. I'm leaving a little space here. And I keep my angle part. That's x to the 1/2. Then I take the derivative of the angle part. Well, if I take the derivative of that, that's 1/2 I'm going to put this in parentheses, 1/2 x to the negative 1/2. So now all I have left is to simplify that a little bit. That would be y prime equals, now 2 times 1/2, well that's just 1, that's nice. This will be 1 over the square root of x times sine of the square root of x. So we could have it like this. We could put the sine square root of x on top over square root of x. There are different ways you could express the answer, but they're both right. It doesn't matter how you express them as long as you've done the computation right there. Okay, this one's a little bit different. We can rewrite that as -3 times sine x to the 1/2. Okay, now hopefully you remember that when we dealt with square or any kind of trig function to a power, well, that power, instead of writing that sine of x to the 1/2, that's the same thing as sine to the 1/2 x. That means those two things mean exactly the same thing. But for the purpose of the chain rule, it might be easier at first if we leave it like this so that you understand how we're using the chain rule here. So when I use the chain rule, I have to take the power times the coefficient and then decrease the power by 1. So for f prime of x, 1/2 times -3 is -3/2. I keep that inside part, I don't change it, and then I take that to the -1/2 power because I have to decrease that power by 1. I have to do this. I have to leave the sign there without taking its derivative because it was my inside part. See that? So I'm doing the chain rule here, but now I have to take the derivative of the inside part. So the derivative of sine is cosine, and derivative of x is just 1, so it's just still going to be cosine x. The derivative of the x part is 1, so that's not going to change anything. So here, notice that because this was the chain rule and my trig function was on the inside of a power, I had to do the chain rule without doing the derivative of the trig function at first. And then I take the derivative of the trig function last because it was the inside part. Okay? And so if you look at that, I've got, well, that -3/2, so the 3's on top, the 2's on the bottom. The cosine x doesn't have a negative exponent, so it goes to the top. The sine x to the -1/2 would now be on the bottom as square root of sine x. And that is my derivative using the chain rule. For the next one, this one's a little bit simpler. This one's a little bit more like the ones we did before. F prime of x, I keep the -10. The derivative of cosine is -sine. We keep the angle part, so the derivative of this is -sine 4x. Then we take the derivative of the inside part, that is 4. So my negative times my negative becomes a positive, 40 sine 4x. That's the derivative there. For this one is another one like that one was. So I'm going to do a quick rewrite of this one. Okay, so for this one, that cosine squared is the same thing as this. That means exactly the same thing. So my inside function here is cosine 3x squared. I'm going to now do the chain rule on that. The chain rule of the outside function, this would be like if I say u is cosine 3x squared, du, or the derivative of that, is negative sine 3x squared times 6x. So negative 6x sine 3x squared. So if I take the derivative of this, 2 times -4 is -8. I keep the inside part, that's cosine 3x squared. I decrease the outside power by 1. Next, I take the derivative of the inside part. Well, the derivative of cosine is negative sine. We keep the angle part. And then we take the derivative of the angle part. So to simplify this, well, I've got, so this is f prime of x equals a negative times a negative, so my negatives cancel out. 8 times 6x, well, 8 times 6 is 48, so we've got a 48x, cosine 3x squared, sine 3x squared. We've used the chain rule to do that. So we take the derivative of the outside function first. We accomplish that by recognizing this is squared. So 2 times negative 4 is negative 8. Keep the inside function, decrease its power by 1. Then take the derivative of the inside function. Derivative of cosine is negative sine of the angle. And then to finish that off, we have to take the derivative of the angle part, 6x. And then we just combine it all together. That one is not to a power, so this one's a pretty simple one. Y prime, we keep the negative 2. The derivative of cosine is negative sine, keep the angle part, square root of x. Then take the derivative of the angle part. Well, that is the same thing as x to the 1/2. So the derivative of that would be 1/2 x to the negative 1/2. And then to simplify, well, negative times a negative is a positive, so it's going to be a positive. 2 times 1/2 is 1, so that's going to be gone. We have a x to the negative 1/2, which is 1 over square root of x, times sine square root of x. And that can be written sine square root of x over square root of x. And that would be your final answer for your y prime. Now, understand, you cannot cancel out the square root of x's. I see that sometimes. That's just a mistake. That square root of x is paired with the sine x. It can't be eliminated there. It can't be factored out. This is another one where my trig function is to a power. So this is another chain rule where my outside function is the sine of 2 minus 4x, and that whole thing is cubed. I'm going to try to do this one without rewriting it first. So I've got y prime. The power of the outside function is a 3. So 3 times the coefficient is going to be 6. I keep all of this the same, so sine 2 minus 4x, but I decrease that power by 1. So that'll be sine squared 2 minus 4x. Now, I have taken care of the outside part. Now I have to take care of my inside part. Now remember, the inside part is the sine 2 minus 4x without the 3. We've already taken care of the derivative of the 3. So derivative of sine is cosine. So I have cosine. I keep the angle part, 2 minus 4x. Then I have to take the derivative of the angle part, which is a negative 4. So then I'm going to just simplify this. That negative 4 multiplies by the 6. That's negative 24. We have negative 24 sine squared 2 minus 4x cosine 2 minus 4x. So you see how they're getting a little more complicated as we go through this chain rule. For this one, we have the chain rule within the chain rule. So for this, notice this 3x plus 5 is to the 4th power. The sine is not to a power. So this is one of the simpler ones, believe it or not. This part is just a little complicated. So we're going to keep the 2. Derivative of sine is cosine. So derivative of sine is cosine. I keep my angle part. I don't change it at all. And then I have to take the derivative of the angle part. Well, that in itself is the chain rule. So I do 4 times 3x plus 5 cubed times the derivative of the inside, which is 3. 2 times 4 is 8 times 3 is 24. So I have 24 cosine 3x plus 5 to the 4th times 3x, and I really should move that to the front. Let's do that. I'm going to move the 3x. So I'll have the 24 3x plus 5 cubed times cosine 3x plus 5 to the fourth. That's probably the best way to express that, because we don't want this 3x plus 5, we don't want anybody to get confused and think that's part of the angle here. It's not, it's separate. Anything separate should always go in the front. Here are 3 trig problems involving the chain rule. I want you to do those on your own, and then we'll go over the answers in a minute. Here are the answers to the first two. 2 times 4 is 8. We keep the cosine x. Then we take the derivative of cosine x, which is negative sine x, giving us this final answer. For this one, we use the chain rule. This is the outer function, so 2 times 1/2 is 1 times tangent 3x. Then take the derivative of the function itself. Derivative of tangent is secant squared 3x, and then the derivative of the angle part was 3. And for the last one, this is the outer function is to the second power. So we do it 2 times secant 3x minus 4. So 2 times secant 3x minus 4. Then times the derivative of secant 3x minus 4. That would be secant 3x minus 4 times tangent 3x minus 4 times the derivative of the inside part is a 3. So 3 times 2 is 6. Here we have 2 secant 3x minus 4, so that's a secant squared 3x minus 4, times the tangent 3x minus 4. They get a little more complicated as we go, as you can see, but as far as the trig functions go, it's not going to get much worse than that. You just have to keep track of each step and don't get them confused with the next step. Keep every part separated and take the derivative of each part separately, and then combine your terms.